Hello and welcome to this session. In this session, we are going to look at the L in solid, which is the third design principle. L stands for Liskov substitution principle. This is often abbreviated as LSP. It is named after a computer scientist, Barbara Liskov, who explained this principle in a book that she authored. Let's look at what this principle says. It goes like this: objects should be replaceable with their subtypes without affecting the correctness of the program. To explain this, we will start with inheritance, which is a basic feature of any object-oriented programming language. Inheritance is also referred to as the is-a relationship. Take the example of a car class. A hatchback extends a car class. So we say hatchback is a car. Let's take another one. We have a bird class and ostrich extends bird. So ostrich is a bird. Another one, fuel and gasoline. So gasoline extends fuel, or gasoline is a fuel. On the face of it, all of this sounds perfect and sounds like textbook examples. But there are hidden problems with this approach, which may not seem obvious at first. Among these three examples, the one in the middle has a hidden problem. Let's take that one alone and analyze further. So ostrich is a bird, and by all means of real-world classification, an ostrich is a bird, all right. As per the biological classification too, ostrich is a bird. But here's an interesting fact. An ostrich cannot fly. Let's see this in code now. So we have a bird class with a fly method. Then we have an ostrich class that extends the bird class. Because the fly method does not make sense for an ostrich, what the ostrich class does is it overrides the fly method from the bird class and leaves it unimplemented. Unimplemented methods are almost always indicative of a design flaw. Now, the statement ostrich is a bird might still be correct, but if we apply the Liskov principle here, which says objects should be replaceable with their subtypes without affecting the correctness of the program, this test fails. Because you cannot use an ostrich object in all the places where you use the bird object. If you do so and someone calls the fly method on the bird object, your program will fail. So the Liskov substitution principle requires a test standard that is more strict than the is-a test. It wants us to move away from the is-a way of thinking. This is a line often associated with the Liskov substitution principle. If it looks like a duck and quacks like a duck, but it needs batteries, you probably have the wrong abstraction. Instead, the Liskov way of thinking should be objects should be replaceable with their subtypes without affecting the correctness of the program. Don't worry if you don't understand this completely now. This was just a very high-level introduction. Let's move on to the next session where this principle will be explained in much more detail.